Modeling with quadratic functions. When solving a problem involving the height of a projectile that is launched into the air or the height of a free-falling object, there are two model equations that are useful. For problems where height is measured in feet, use the equation h of t equals negative 16t squared plus v naught t plus h naught. For problems where height is measured in meters, use the equation h of t equals negative 4.9 t squared plus v naught t plus h naught. There are two subscripted constants. The initial upward velocity is given by v naught, and the initial height is given by h naught. For a free-falling object, the initial upward velocity is 0. So, for free-falling objects in feet, use the equation h of t equals negative 16t squared plus h naught. For free-falling objects in meters, use the equation h of t equals negative 4.9 t squared plus h naught. The gravity constants are negative 16 feet per second and negative 4.9 meters per second. Each of these is half the acceleration constants for Earth. Here's an example. A football is thrown into the air from the top of a building, 50 feet above the ground. Its initial upward velocity is 20 feet per second. What is the equation that can be used to model the height of the ball after t seconds? How long does it take for the ball to hit the ground? Since the initial velocity is in feet per second, we'll use the model h of t equals negative 16 t squared plus 20t plus 50, where v naught equals 20 and h naught equals 50, because we're 50 feet above the ground and the initial upward velocity is 20 feet per second. To determine when the ball hits the ground, solve h of t equals 0. So we want the height off the ground to be equal to 0. So when we set it equal to 0, we can divide everything first by 2, and then we can factor, finding that t equals 5 over 2 seconds.